Dear learners, welcome to Physical Pharmaceutics 5th experiment. Aim that is to measure the viscosity of liquid using an Ostwald viscometer. Aim of our practical that is to measure the viscosity of liquid using an Ostwald viscometer. So we learn about in this practical what is viscometers, different types of viscometers. Also, a procedure to determine how to determine the viscosity of liquid. Viscometers, procedure, observation, importance of this practical. So one by one we'll discuss about in this practical. So first upon viscometers. Viscometer means are the device used to measure the viscosity of fluids. Viscometer means viscometers are devices used to measure the viscosity of fluids. Viscosity means thickness, thicky, semi-solid form. In pharmaceutical, that is a semi-solid form thickness as well as creams. So simply thick viscosity, those are measured from viscosity by that is viscometers. So there are several types of viscometer for different types of fluid measurement. Some of the main types include rotational viscometer, capillary viscometer, falling spear viscometer, vibrational viscometer, cup and bob viscometer. Rotational viscometer in that Brookfield viscometer, cone and plate, and capillary viscometer, Ostwald viscometer. So our practical that is to measure the viscosity of by using Ostwald viscometer. So first upon Brookfield viscometer, rotational viscometer, one of the example that is Brookfield viscometer and cone and plate viscometer. So Brookfield viscometer measuring the viscosity by rotating a spindle in the fluid and detecting the resistance to motion. So Brookfield viscometer measuring the viscosity by rotating a spindle in the fluid and detecting the resistance to motion. Next, cone and plate consist of cone placed above the flat plate and the gap between the two is filled with fluid, and the torque which is measure the force needed to rotate the cone is measured. Cone and plate in that consist of cone placed above the flat plate. The gap between the two is filled with fluid and the torque is needed to rotate the cone is measured. Torque means measure the force. Next, second, that is capillary viscometer. That is capillary viscometer means measure the time taken for a fluid to flow through a small diameter tube under the effect of gravity or pressure. So capillary viscometer, Ostwald viscometer measure the time taken for fluid to flow through a small diameter tube under the effect of gravity or pressure. Falling spear viscometer means a ball is allowed to fall through the fluid and time is taken to travel the certain distance is measured, determine viscosity. Cup and bob viscometer consists of cup holding the fluid and bob suspended in fluid. Bob is rotated and by torque the viscosity is determined. So torque is needed which is measure the force. And vibrational viscometer, viscosity is observing damping effect. Viscosity is observing damping effect. Means damping effect means slow down or stop down motion or oscillation vibrating in the fluid. So these are the different viscometers: rotational viscometer, capillary viscometer, falling spear viscometer, vibrational viscometers, cup and bob viscometer. So another point, that is types of fluid. Types of fluid, in that Newtonian fluid and non-Newtonian fluid. Newtonian fluid, that is water, means single phase homogeneous water. Example, that is benzene, syrup, acetone, glycerin. This is a Newtonian fluid. And non-Newtonian, in that plastic, pseudoplastic and diluent. Rheology, the branch which deals with flow of fluid or flow of liquid and deformation of solid. The branch which study of flow of liquid and deformation of solid, that is called rheology. Newtonian flow, in that which follow the Newtonian law, which is, that is water, glycerin, benzene, syrup solution, that is a Newtonian fluid. Non-Newtonian fluid, in that plastic, pseudoplastic and diluent. Plastic, in that ointment, gel, cream. Pseudoplastic, natural synthetic polymers. And diluent, deflocculated suspension. Paste, means paste, in that first plastic flow, in that shear thinning, and diluent flow, that is shear thickening. So that are the types of fluid. So next procedure, how to determine viscosity. First, need a set of equipment, means that is Ostwald viscometer. Second, preparation of liquid. First, set of equipment. Second, preparation of liquid. Third, filling the liquid in viscometer. Fourth, measuring time. 5, repeat the measurement. And 6, calculating the viscosity. And 7, analyze and write the result. First, set up the equipment. Preparation of liquid, means that is acetone. Filling the liquid in viscometer. 4, measuring the time. Repeat the measurement, means precision. 6, calculating the viscosity. 7, analyze and write the result. Set up the equipment. The Ostwald viscometer consists U-tube, U-shaped tube with 2 arms, with one arm shorter than other. Make sure the viscometer is clean and dry before use. Place the viscometer in vertical position and confirm that the liquid to be tested does not bubble or leak. Ostwald viscometer consists U-shaped tube with 2 arms, one arm shorter than other. Make sure viscometer is clean and dry before use. Another, place the viscometer in vertical position and confirm the liquid to be tested does not bubble or leak. म्हणजे विस्कोमीटर आहे ते लीक नसलं पाहिजे किंवा बबल ऑकर झाले नाही पाहिजेत. दॅट इज अ प्रिकॉशन विल टेक. सेकंड, प्रिपरेशन ऑफ लिक्विड. द लिक्विड हुज विस्कोसिटी यू आर मेजरिंग शुड बी कन्सिस्टंट. Constant temperature, as viscosity is temperature dependent. Next, if necessary, prepare the liquid by removing any air bubbles and confirm it is homogeneous. Next, filling the viscometer. Fill the viscometer with liquid to be measured. Make sure liquid is above upper bulb and reaches just below the upper neck, the viscometer. This is to ensure that the liquid will be drawn into the both arm for measurement. A and point B. So point A and point B have to make sure that the liquid is above the upper bulb and reaches just below the upper neck of the viscometer. Next, measuring the time by using stopwatch. Record the time taken of liquid pass between the two marked points on viscometer. The time taken will be proportional to the viscosity. Repeat the measurement for accuracy, precision, repeatability 3 times to calculate an average time. Calculation viscosity formula, analyze and write the result. Compare the measured viscosity with standard viscosity value and assess the consistency and properties of liquid. Formula used for determining viscosity. N2 equal to rho 2 divided by rho 1 into T2 divided by T1 into N1. N2 means is the viscosity of sample, and rho 2 is the density of sample, and rho 1 is the density of reference fluid like water. T1 is time flow for reference fluid water, and T2 is the flow time for the sample, and N1 viscosity of reference fluid, usually water. So this is the formula for determining viscosity. Observation table: density of water 0.99, density of test solution acetone 0.78, viscosity of water, that is 1, room temperature 20 degrees Celsius. We carried out the practical. Observation table: liquid sample, water 3 times reading will carried out, time of flow, mean time, density and viscosity. Formula: N2 equal to root 2 rho 1 T2 T1 and N1. So putting the values, and result will got the viscosity of given liquid sample is 0.54 centipoise at 20 degree Celsius. Next, importance of this practical: formulation of consistency means thickness and viscosity maintain is needed. So viscosity and pharmacological action is a relation between, means higher the viscosity, slow drug release, and lower the viscosity, higher drug release, means spreading. Higher viscosity, localized action, means the drug release is less. So that is the relation. Formulation consistency means thickness and viscosity is maintained need for which purpose? Viscosity play an important role in formulation of liquid pharmaceutical product including syrup, suspension and emulsion. Correct viscosity help to get desired therapeutic effect and ease of administration. So also administration, viscosity and therapeutic effect also relation. So formulation consistency. Next, drug release and absorption. The viscosity of pharmaceutical formulation can affect the rate at which drug is released from dosage form and subsequently absorbed by the body. Monitoring viscosity is essential for controlling drug release profile. Stability purpose also, the viscosity of pharmaceutical formulation can also indicate the stability over time. Also, a significant change in viscosity may suggest degradation or changes in formulation. Another, processing and manufacturing. During pharmaceutical manufacturing, the viscosity of raw material and finished product affect processing conditions such as mixing, pumping and filling. Knowledge of viscosity is important for consistent production. So scale up and consistent production, and last application, that is quality control. So formulation of consistency, drug release and absorption, stability, processing and manufacturing, and quality control. So also absorption also depend, as well as bioavailability also depend. So that's why viscosity is important for correct and to get a proper viscosity monitoring is needed. So that's this practical is helpful for to understand what is the applications, formula, how to calculate procedure, different type of viscometers. Next, so watch this practical, so you have to clearly understand. First, distilled water, this is Ostwald viscometer, U-shaped point A and B, fill the liquid. So this is the filling of liquid. stopwatch using count the time, reading time calculated up to the point B and point A. So acetone sample. So hope you understand this practical. And last one, the viscosity of result will return. The viscosity of given liquid sample was found to be 0.54 centipoise at 20 degrees Celsius. Hope I hope you're all curious, or you understand this practical. Thank you.